Alright guys, so here's page 1 of Unit 3. In Unit 3 we're going to look at quadratic function. So the first thing we're going to look at the graph of a quadratic function. It looks like this. It's kind of like a U or a V shape. It's more of like a U because it curves here. And we call it a parabola. And this is the parent function. So this is the shape of a quadratic parent function. So a couple of things here. So the vertex, so here, of the parabola is this point right here. And then, it could be a low point, or if it's upside down, it could be a high point. If the A is positive, so if A is greater than 0, so this number in front of the X is greater than 0, then it opens up. Okay, so it looks like this. And also the vertex, we call this a minimum point. Okay, and then if your A, the number in front of your X, is negative, it opens down. And then here, like this. And the vertex here, we call it a maximum point. Okay, and then so here, if your A is greater than 1 and this absolute value tells you that this number could be positive or negative as long as it's greater than 1, we call it a vertical stretch. What that means is, so if this is your parent function right here, a vertical stretch, if your A is greater than 1, it would have something like this. It'd be stretched up. And then if this number is between 0 and 1, then we call this a vertical compression. Okay, so basically if this is your parent function right here, a vertical compression means that it's going to be wider than the parent function. Okay, so this right here is your vertical stretch, and this right here will be your vertical compression. The H tells you the vertex, so basically whenever you look at the vertex, the X tells you your horizontal shift. And we look at this example. And then the K, the Y coordinate of your vertex, tells you your vertical shift, how far it moves left and right. And then this one, how far it moves up and down from the middle of the point, middle of the graph, which is, we call it the origin. So let's look at some of these graphs here. So for the first one, we want to find the vertex of this. So let me go ahead and get my Desmos. I'm just going to use my Desmos on my phone. So here it says that I'm going to plug in. So you don't really have to put the f of x part. You can just plug in this part here. So you have x minus 3 squared minus 2. And then it's nice in Desmos because if you touch the vertex, it tells you what it is, which is 3, negative 2. So 3, negative 2 is my vertex. And the vertex is a minimum point because it is the lowest point right here. So let me just write here 3, negative 2 is going through over here and then 1, 2, 3, somewhere over here, and it's going up. Okay. And then it's asking for the horizontal shift, so how far did it move to the left or right? So since this is positive 3, it moved to the right 3. And then negative, it moved down 2. So it moved from here to here. It moved right 1, 2, 3, and down 1, 2. And this is not, it's neither a vertical stretch or a compression because it doesn't have a number in the front here, and it's a reflection it's not a reflection because it's not going upside down. So it'll be a reflection only if it's a negative function. So let me try number 2. So we're going to just plug it in Desmos. So you have here negative 2 parentheses x plus 1 squared plus 4. First of all, it is a reflection. And then the vertex here is at negative 1, 4. What is the vertex? Is the vertex a maximum or a minimum? It is a maximum point because it's the highest point. The horizontal shift is left 1. And then it's up 4 units. And now is it a stretch or a compression? To do that, we're going to look at A. So my A here is negative 2. And then we look at to see if it's greater than 1, and it is greater than 1. But we look at the absolute value of A, which is, we don't care if it's positive or negative. We just look at the 2 part. And since it's greater than 1, it is a stretch. Okay? And if you want to see it compared to the parent graph looks like that x squared, but it's kind of hard to tell, so let me turn it into an upside down, and then it's still kind of hard to tell if, oh sorry, there's a 2 here. Okay, it's still it didn't change the vertex, it's still, but if you notice it's skinnier than the parent graph, and if you want to kind of see it compared to the parent graph, you can just take all this off. Oops. Okay, see how it's a little skinnier. Okay. Yeah. So I'm going to just look at the next 2 problems here. Here is problem number 3. So I graphed it. Here's the vertex, negative 4, 0. It is the, oops, my bad. It is a maximum point because it is the highest point. It moved to the left 4 units. There is no vertical shift. It didn't move up or down from the origin. And it is neither a vertical stretch or a compression because there's not a number in front of your x. And yes, it is a reflection. Here's number 4. So here's the graph, and the vertex is at 0, 3. It is a minimum because it is the lowest point. There is no horizontal shift because of the 0. It shifted up 3 for the vertical shift. And now this is a compression because A is equal to 1/2, the number in front of the x. And this 1/2, the absolute value, like it doesn't matter if it's positive or negative. If it's between 0 and 1, so 1/2 is 0.5, so that's between 0 and 1. So that makes it a compression. And let me go ahead and put the parent graph in, x squared. And then let me move it down. And the black graph, which is our f of x right here, is wider than the parent graph, which is in red. So that's what makes it a compression. Here's number 5. So here's my vertex, 1, negative 2. And then the vertex is a maximum since it's the highest point. There's a horizontal shift of 1, a vertical shift down 2, right 1 and down 2. It is neither a horizontal, a stretch or a compression because there's not a number in the front. And then is there a reflection? Yes, because it's pointing down. Okay, so for number 6, here's my vertex, negative 5, negative 3. Here, I plugged it in here. It is a minimum because it is the lowest point. It moved over to the left 3 and down 3. Left 5 and down 3. It is a stretch because the number in the front here is greater than 1. So that makes it a stretch. And it is not a reflection because it's just pointing up. Okay, so for this question, we're going to look at a bunch of vocabulary words. Okay, so that we're going to just look at this graph and we're going to analyze and see what all of these different are. So the first one is the vertex. So here's the graph of the vertex. So the vertex, so this is at 5, -2. It's not negative, it's +5. So transformation just means, like, is it moving up and down, and is it a stretch or a compression? So it is moving to the right 3 units. Sorry, I keep saying 3, 5. And then it is moving down 2 units. And we know that this is a stretch, or a vertical stretch, because it's the number in the front is greater than 1, so it's going to be a little skinnier than the parent graph. Now this one is asking you for the domain. So the domain you're going to look at from -infinity to +infinity, and notice this graph keeps going to the left. The higher it goes up on the left, it goes to the up, it goes to the left, and even on this side it keeps going to the right. So for all of your quadratic functions, it's going to be all real numbers. So from -infinity to +infinity. Okay. The range. The range is, you start from here, the lowest point here, which is -2. So y is greater than or equal to -2, since everything is greater than -2. If it was upside down, then we would say y is less than or equal to, and wherever the y coordinate of the vertex is. We did skip increasing and decreasing, so you don't have to worry about those. Zeros of a function. So zeros are the x-intercept. So where is it crossing the x-axis? 4 and 6. X equals 4 and x equals 6. Okay. Actually, I am going to come back to increasing and decreasing intervals. So increasing and decreasing intervals, we're going to look at the this is my turning point, right, at 5, -2, which is my vertex, but it's also my turning point. So from -infinity until my turning point at 5. So from -infinity until 5, it is decreasing. Whoops, -infinity until 5. Okay, it is decreasing. And then from 5 until +infinity, it's increasing. So we're going to put 5 until +infinity, it's increasing. Now the end behavior is talking about what is your function doing as far as your f of x is going to +infinity and -infinity. So on both of the sides, they both are going up. So we're going to say is +infinity, +infinity. Okay, let's try the next page. Okay, I'm going to go ahead and graph this. I know it's right there, but I'm going to just graph this in my graphing calculator. Negative x plus 2 squared plus 3. So the first thing is to ask me for the vertex, so that is at -2, 3. Transformation, well, it moved to the left 3. Sorry, left 2, and then up 3. It doesn't have a stretch or a compression, but it is a reflection because it is going down. Okay, the domain is going to be from negative to positive, so it's going to be all real numbers. Now the range, so we're going to look at the y coordinate of the range, which is at 3. And y is less than 3, so we're going to put y is less than or equal to 3. Increasing and decreasing, so where is the function going up? So from -infinity until here, the x coordinate, which is at 2, it is increasing. So I'm going to put that here. So from -infinity until -2, it is increasing, and then from -2 until +infinity, it's decreasing. +infinity on the x-axis. Now where is it crossing the x-axis? It's going to be at, and Desmos does a really good job if it's the decimal. That's the y-intercept. Is that the y-intercept? No, that's the x-intercept because my y is 0, so that is the x-intercept. So you have x equals negative 3.732. That's one of my zeros, and then the other one is that x equals negative 0.268. And my end behavior is, well, they both are going down, so it's going to be negative infinity, since they both are going down. Okay. Okay, so here's my vertex, which is at 1, 4, which means they move to the right 1 and up 4. And it is a vertical compression because of the 1/2 makes it look like a wider graph than the parent function. The domain is all real numbers from negative to positive. That's always going to be the case, okay? The range is y is greater than or equal to 4. So wherever my y coordinate of my vertex right there, so range is y is greater than or equal to 4. Now my increasing interval is, where is my function going up? It's going up here. You're like, well, maybe it's going up here too, but if you go from left, if it's going in this direction, it's going down and then going up. So this is decreasing. So from negative infinity to 1, it's decreasing, and then from 1 to positive infinity, it's increasing. Okay? There are no x-intercepts, so no zeros, no real zeros.
Yeah, no real zeros.
And then the end behavior is positive, 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 because they both are going up.
Yeah.
Okay?
Up, up, up.
Okay, so here's the next page. So the vertex, let me go ahead and type it up. We have here negative x minus 3 squared, x minus 3 squared plus 1. Okay, so my vertex here is at 3, 1. It moved right 3 and up 1. It is a reflection because it's pointing down. It doesn't have a stretch or a compression. The domain is going to be all real numbers because it's always going to be that for quadratics. And the range is y is less than or equal to 1. Okay, and then increasing, so it's increasing. I wrote it a different way, saying x is between negative infinity to 3, so from negative infinity up until 3, it's going up, so it's increasing, and then decreasing is 3 to positive infinity, it's decreasing. X-intercepts for this are going to be at 2 and 4. And then since they both are going down, it's going to be negative infinity and negative infinity. Alright guys, that's lesson 1. Thanks.